What we're going to cover today is an extension of what we talked about last time. What did we talk about last time? Anyone? Mean, median, and mode. And what is the mean, median, and mode? For our friend. Summation?
Over n.
Exactly, that's going to come up in a bit. What's the median? The middle number. Excellent. And what does that mean?
Half the observations are smaller and half the observations are larger than that middle number. Right. Half is half of that. And what's the mode?
Right. No, exactly, the most frequent number. Let's say points out the most frequent number. Are the most frequent values, right? Usually it's done with what kind of data? Mode is covered with what kind of data? Categorical data, right? Because continuous data, I mean, it could be quantitative data as we talked about, like if you don't have a lot of numbers you're working with, but generally it's categorical because it doesn't, you know, if you have like an infinite number of possibilities, then any one possibility probably won't show up that much, right? The modal GPA is probably 4.0, right? It might be the most common GPA because once you start moving away from that, then it's like there's a lot of fluctuation, right? But obviously 4.0 is not really a good representation. So while this is the equation to calculate the average, no one actually calculates it by hand. It's kind of useful to know how it works because sometimes you have data that is not well summarized. You know, you might only have a pie chart or something and you should just have some intuition as to how this is calculated. But in practice, for everyday observations, for everyday data, you don't calculate it by hand. You have Excel calculated for you. And that's what we're going to talk about today, a lot of stuff with Excel. So if you go to my website and pull up dataset 2, I believe it's dataset 2. It should be Disney sales data. Wait for Excel to load. Yep, so here we have Disney sales data. Again, remember to hit that enable editing option. Let's zoom in a little bit. Let's expand that. I always want to expand that a little bit. Okay. So first, I want us to get comfortable working with this data and sort of viewing it. You note that when I scroll down, I lose sight of what's going on here, especially if I zoom in. I lose sight of the top row, which is important because those top 3 rows are labels. I would like to be able to see that. Also, too, when I scroll to the right, I lose track of which row is which year. Right. That would be nice too. This, by the way, is of course all sales data. The sales data is in what? Millions. So Disney in 1997 made about how much? Its studio made about how much in revenue? A little shy of what? 7, did someone say 7 million? 7 billion. Right, I think someone said 7 billion too. Do I remember? So this is what we talked about before. Look at the values, look at what everything's expressed in terms of. This is 6,981 million, or about just under 7 billion. Just under 7 billion. Okay. I think I do want to angle now. So I would like to, when I scroll down, I would like to see what the individual titles are. When I scroll to the right, I would still like to see the year. So just to get us set up and working with this, let's learn how to do that. Does anyone know how to do that? Okay, great. There is a simple way, and then there is a good way. Let's do the simple way first. So the simple way is you go to the View tab, right there, and then you select Freeze Panes, and you just tell it to freeze top row. And that is a simple way to do it, but you know it's not what we want. We only get that very top part right there. That's really useless. Let's unfreeze. We could, if we really want to, freeze first column, which is nice because it does get our years. All right, that's pretty cool. Freeze the first column under the freeze panes. But, of course, we don't get our top 3 rows. So the simple ways to do it are just hit those 1 buttons, the freeze top row, freeze first column options. Let's unfreeze. But we don't want to do that. We want something a little bit more elaborate. We want to include these 3 right here across the top. And we would also like to be able to grab, at the same time, this first column right over here. So Excel has a custom option, and you can honestly see the custom option in the little logo for freeze panes. You see it has that highlighted box and then the slashes through the cells around it, forming a box. Those slashes are ones that are frozen. Basically how this works is you identify the areas you want frozen. It's always going to be in the upper left area of your screen. So these 3 rows we want to hold, and this column we want to hold. Which means this area, starting with the corner of B4, this area we want to vary. So select B4, because it is, don't double click, just select it. 1 click. It is in the top left cell of the area you want to change as you scroll. Then use that first option, freeze panes. Right? That's what that symbol means with the circle. I'm sorry, with the highlighted box and then the stuff around it. When you do that, you scroll down, all 3 of those things are frozen for you. And you scroll to the right, and this is. And so when you do this, so you can see, oh, interactive growth for 2012 was negative 14%. And our media sales were 19 billion. Media network, I should say media network sales. Does everyone get that? Yeah, we good? So I will, yeah, sure, I will. So I'll unfreeze just to show you what happened. So first thing you do, make sure you're in the View tab. Select the upper left box that you want to, of the area you want to vary. This larger box right here, you want to vary. And then select the first option under freeze panes. And then everything above that box and everything to the left of that box will be static as you scroll. So it's a nice thing to be familiar with, because often too, you sometimes are working with data. There's like a lot of columns. There are a lot of rows, and it's nice to be able to hold everything down because you can always see what you're looking at. Okay. So let's calculate the mean. Let's just put that right here. I don't know, put it right here. So it's nice to title things. Oh, you know, actually even better, let's put it right here. Because we've frozen that column, right? So let's put it right here. And let's also get the median too. And let's do the mode. And sometimes it's nice to bold it. I can bold it like this. Maybe double click, hover between the A and B so it gets that little symbol, and double click so it's wider. You can also, if you want everything bolded, you can just bold the whole thing. So, you know, highlight 23, 24, 25 and hit Control B. Well, you know, that. Control B obviously turns it on and turns it off. Okay, so we want to figure out what the studio mean is. How do you think we figure that out? So before we highlight the columns, we will need a command. And so the secret to Excel, and I'm going to say this many times, so don't worry if you miss it, but the secret to Excel is to press the equal button. Yeah. Yeah, absolutely. Right. So the secret is to press the equals button and to start typing vaguely what you're interested in. And you might have to type a couple of different things, but it will give you suggestions. Like if I want the mean. Well, I don't see the mean. I see the geo mean, which we'll talk about later in the class, but I don't see mean. But as you noted, Amanda, another word for mean is average, because that's what most people call it. And so Excel programmers said, fine, we'll just call it the average. So as I started typing, you see that I've highlighted average and I hit the tab button, and that tab button will complete it. Don't do as I've seen people do. It's like, I want the average. Oh, I see it. And then you hit, and then you make the open parentheses. Don't do that, because a ver doesn't mean anything. Excel doesn't know what a ver is. It's not anything. You want to hit that tab button so that it gives you the full command, the full function name. Okay. So then what do we do, Daniel? Yep, D4, 321. So now we're just going to highlight. It'll be fun all the way up to the top. And now if you want, you can close the parentheses, or you can just hit enter. I usually just hit enter because that saves me a step. It'll put the parentheses in automatically. And because I bolded it, so now we have an average. The average is, also about 6,900. About 6.9 billion. Okay, what about anyone questions? Let's do median. So how do you think I do this part? Equals median, exactly. It makes it so easy. So we just start typing. I have MED, I see median, I'm just gonna grab it. Again, hitting that tab key. And then what do we do? Michael? Highlight our data, and I press enter, and now I have the median. Note the median also slightly higher than the mean, but not that much higher. So that kind of tells, really just not higher at all. What is that, like 18 difference? So that kind of tells us that there's no really weird outliers, or if there are outliers, there's outliers on both sides. There's no outlier dragging the median way lower than the mean. There's no outlier dragging, the mean way lower than the median. There's no outlier dragging the mean way higher than the median. If there are outliers on either, they're pulling in opposite directions. Okay, simple enough? Let's do mode. How do you think we find mode? So you're getting ahead of yourself, but yeah, we're gonna have problems, but let's remember how to do it. So equals mode. So now it's giving you 3 options for mode. The third option is honestly the one I'm used to, because that's from an older version of Excel. So you can hit that one if you want. It has a yellow triangle on it, if you can see it. That's just a reference to, this is from an earlier version of Excel, but we still support it here. It's compatible with this version. But if you don't want to do that, you can just use the single. I don't really work with the mode multi, so we can just use the mode single, SNGL. Either one works, mode or mode single, and so we just hit tab, and then we highlight. And what do we get? Yeah, we get an NA. What does NA mean? Not applicable, because as Amanda, what'd you say? As Amanda said? Yeah, they're all different, right? There's no most common value. So a mode here, like all continuous data, really does not make sense. It does not make sense. When does modes make sense? I said earlier, categorical. So take a look at our most growth section. What kind of data is this? Well, what does this data represent? Let's start with that. It's categorical data. What is it? Like, what do you think I'm trying to convey with the categorical data? I usually give descriptions of everything. I gave stock price descriptions. I didn't give Disney sales descriptions for some reason. I guess I thought everything was obvious. So what this is saying is, in 1998, of the 5 sections we have, the one with the most growth from the previous year was interactive. And so I gave each one of these a number so we can calculate the mode. Studio is 1, consumer products is 2, parks and rec is 3, parks and resorts is 3. Interactive is number 5, so there's a 5 there. In 1999, the highest growth of the 5 sectors was parks. In 2001, the highest growth was studio, et cetera, et cetera. So this is categorical data. This is essentially award winner, the sector of the year kind of thing, the most improved kind of thing. So we're curious, which sector got the most improved? Which sector most often did the best? So we can find it now by doing the mode, and we can just, of course, we want to just copy and paste this over, because then we'll update cell references and we'll just delete that one. Yeah, parks. Parks is 3. By the way, if you the reason why I had to add numbers, even though I told you not to, is I needed some number because Excel needs numbers to figure it out. All right? If I try to do it over here, then it doesn't know what it's talking about. So I had to use numbers there because otherwise Excel doesn't know what I'm talking about. Any questions? So we obviously will not need a mode for anything else here because all of this other data is not categorical. All this other data is quantitative. And continuous, I should say continuous. So let's imagine I would like to have this mean and median data for all of these other sectors, for the consumer products, for parks and rec, for consumers, whatever that is on the far right. I can't read it. Media network, interactive, maybe even total too, just for fun. How would I do that? Please. So I would like to have mean and median for right here at sales and consumer products, and then for parks and rec, for parks and resorts, and for media networks, et cetera, et cetera. Like so sort of like, and then press control and do that, control and do that, and then V. You can do it that way. Like that worked. So if people didn't, I usually don't do it that way, but that works. If you had no idea what I just did, I highlighted D23 and D24. I pressed Control C to copy. I then highlighted 23 and 24, press and hold Control. I'm sorry, F 23, 24. Press and hold Control. H 23, 24. Press and hold Control. J 23, 24. So I am picking little parts of this Excel sheet and saying only paste in those, and then hit Control V and it pasted only in those. So that's option 1. And that allows us to skip over the growth rate column. You could, of course, just drag across. But the problem is if you drag across, as we will find out, you don't really want to use the arithmetic mean, do a growth rate. You kind of want to keep it blank. So that's option 1. The problem with doing that, and you can absolutely do that, Julia, but the problem with doing that is then you have to individually select each one as you go across, and that's kind of annoying. It would be nice if there was a way to drag. And so the way that I recommend for people to do is to highlight that box of what you want. Let me scroll up a little bit so you can see. Oops. Highlight the box of what you want, including the blank area. And then when you grab that, that wonderful green square right here in the corner, and you drag across, Excel will copy this whole area right over here to this section, including the two blank areas. And then you can just drag across however far you want to go across. And then you have to select any individual thing. And it will skip over the blank stuff for you because you told it to when you did that initial highlighting. Yeah. So remember, when you highlight something, and you are telling Excel, I like this thing, this box that I highlighted. And then when you grab that green, mouse over that green square in the corner, click and drag, you are saying, I want you to now copy and paste that box one for one wherever I'm putting it. And because we highlighted this blank area here, when we copy and paste it, it will then copy and paste, quote unquote, a blank area over and over again, allowing us to skip every other one. Did this and copied and pasted across. Now it's not skipping over these and it's getting these. The reason why these are 0 is because they're not 0. They're very small. The values are less than 1 because it's giving averages based on growth rates, which are all less than 1. Well, you can just, what do you mean? Like, you can do a percent and you can see what they are if you want. And then you can do this. And that at least gets you the median, which is something that might be worthwhile to have. I know I have to do this whole box because I want this one to be regular numbers and I want this one to be percents. And so that formatting, I have to tell Excel, sometimes you want regular numbers, sometimes you want percents. Now go back to regular numbers, now go back to percents. You can't do that. But, and this is what we're talking about before, that mean number for growth rates is wrong. So let's talk about how you actually calculate that value, that average growth rate, because you can't do it the typical way. And let me show you why. Let's imagine I had a block that was 1 foot tall, and I had another block that was 9 feet tall. What is the average height of these blocks? That's right.
5 feet.
5 feet. Right, absolutely. The average is 5 feet. We agree that if I take this 1 foot block and put it on top of this 9 foot block, I would get how many feet? 10, right? 1 plus, not a trick. Now, let's imagine I had 2 blocks that were the average height, and I stacked them on top of each other. What is the total height of this tower? It is 10. I should put it inside. This is 9. Right? Again, yeah, exactly. It is also 10 feet. So this is sort of a way to test to see if an average makes sense or not, if an average is correct, is by assuming every value is the average and then seeing if the aggregate result is the same as when they were all different, when the observations were all different. That's a way for us to test to see if an average is correct. Good? Does that make sense? Okay. If you're like, the hell is he talking? This is so simple. Hold on to your butts. Let's imagine I have like $10,000. Someone has $10,000, not necessarily me. And they put it in the bank. And let's imagine the interest rate is 1%, which means the growth rate of that money is 1%. How much money do you have at the end of that year? Mm-hmm. And how did you find that? Yeah, exactly. So you take that 0.01 times our starting value, we'll just call it like S, plus S. Or, if you want, S times 1 plus 0.01. That 1 we're adding is that principal, that starting value. Let's imagine that I have 9% growth rate on that. How much money do I end up with? I'm going to take that value of 10,100 and multiply it by 1 plus 0.09. $10,909. And note that that's absolutely right. And that makes sense, right? Because that $900 came from the $10,000 right here. And that $9 came from this $100 right here. Right? You earn interest on the interest, right? That's compound interest. That's the power of compound interest. So what's the average interest rate? Well, what's the average interest rate here, arithmetically? It's 5%, right? Same as over here, right? So let's test to see if that's correct. Because if it's correct, then we should have, if we have 5% interest followed by 5% interest, we should get the same result. Well, 5% this becomes 10,500. And then what's 5% on that?
10,000. Oh, sorry.
No, you're thinking of 1,000.
Sorry.
And then what's a 5% of this? 5% added on, what? It should be, so we should have, might have to double check my math, but it should be that. So note there is a mismatch. If you're trying to calculate the average growth rate of something, do not take the arithmetic mean, because the result will be slightly too high. Sometimes it might be somewhat too high, it depends on how bad it is, but it will always overestimate the actual average. And the reason why is because there's an asymmetry between how we calculate the overall rate here through addition and how we calculate the overall rate here through multiplication. So we can't use the arithmetic mean. We have to use its cousin, the ugly, ugly, ugly cousin, the geometric mean. First, let's start with our friend, the arithmetic mean. As noted, that is the sum of everything divided by n. The geometric mean, or what Excel calls the geomean, so just as a helpful hint, it will do this for you when I'm about to write, but it's important you know what's going on, is the nth root, I should add these, of the values. Does everyone know what this notation is, this giant pi symbol? Does everyone know what it is? So this is, as we talked about, summation notation, and each value is added together. The giant pi symbol is multiplication notation. It is not 3.14. Pi in this class never is 3.14. Giant capitalized pi is you're going to take all the following values and you are going to multiply them together. Good. So we know what this square root with the n means. It means the nth root. So if n equals 2, it is the square root. If n equals 3, that's the cubed root. Just as 2 to the power 4 is, 2 to the 4th, the fourth root would be 2 to the power of 1/4. So note that they're opposites. Much like multiplication and division are opposites. Much like addition and subtraction are opposites.
Are you familiar with this? Have you seen the nth root and so forth? If you were going to take something to the 8th root, you would then use the caret triangle on your calculator or something, and then parentheses 1/8 rather than just 8.
8th power, multiply together 8th time, and so on. Are we good so far? No one's freaking out? No one's running outside? Great. I want you to take a moment and appreciate the symmetry between these two equations. Because it's going to get a little bit more complicated. Addition is a very basic function in math. What's the opposite of addition? Subtraction. What is one step above addition? Multiplication, right? What's the opposite of multiplication? Division. What is one step above multiplication? Exponential expiation, is that what? Whatever it is, it uses the little caret thing. All right. What is the opposite? I just said it of this. All right. So taking something to the power of n, the opposite is the nth root, right? So note, the mean starts by adding everything together and then divides. So this is our arithmetic mean. The geomean starts by multiplying everything together and then taking the nth root. So this will divide by n, this takes the nth root. So if you want some intuition as to why this equation looks as it does, that's the reason why. It is just a mirror image of the arithmetic mean, but one step higher.
Good. Now you can sort of do this in your head.
At least this stage, because we have a 1 and 9, I kind of erased the 9. And if you take 1 times 9 is 9, the square root of 9 is 3, the geometric mean between 1 and 9 is 3. The tricky part is we're not using 1 and 9, we're using 1% and 9%. We're using growth rates. So this geometric mean that Excel has built into it, we are going to have to make some little tweaks to. To understand those tweaks, let's unpack what happened here. We decided to multiply, let me put it this way. We took 10,000, our starting value. We multiplied it by 0.01. That was this step right here. And then we multiplied this result by 1.09. Right. Does everyone see how this is the same thing as this step process here? Does everyone see why I added in that 1? Because that's super, super, super important. Please tell me if you do not know where that 1 came from. Who said no? Yeah. So, do you know what a principal is? An investment? Okay, it doesn't matter. Up here, you see how I had that 0.01 multiplied by the starting value, and that gives me how much it grew. And then I added it to the starting value because now that's how much I have, right? I didn't do what I started with. So if you do a little bit of dividing out, factoring out that S, then you would get 1 plus the growth rate. So we still have what we started with, and we have extra. We still have what we had the period before, and we have extra. That's what that 1 is. Okay. Are we good? So we can generalize this with this. Multiplication notation, 1 plus xi, I equals 1 all the way out to the nth unit, times our starting value of s. If you see this equation, sometimes they have that as P for principal. If you know your investment lingo, principal is just investment term for the starting value, what you put forward. So you sometimes see it with P. But this is the basic equation. So if we are going to find the geometric mean, you see that there is a connection here. The difference between this right here, the multiplication times x, and this one, multiplication and x, is this principal that we added in, that plus 1. So how you will find the geometric mean in Excel is you will add 1 to all the values, and then tell Excel to multiply all those values together and then take the nth root. And that step is the geometric mean function. And then you, at the end of that geometric mean function, subtract 1. Does everyone follow? Okay. Let's do it.
Going back to our Excel sheet, let's make a new sheet.
Well, I just want a blank area to work with. I don't want to deal with any of this nonsense. Let's make a blank area. So let's see. Let's first start in by putting in our 1% values and our 9% values. Now, and then let's also put in our $10,000 principal right here at the top. Give it a little $sign. We don't really need to know the pennies. So note, our result should be this value times 1 plus 1% times 1 plus 9%. So that's what we were doing over there, over with the starting value times the multiplication, et cetera, et cetera. And that's what we got as a result. Appreciate that when we put in 5%, go, drag this over, drag this over. We do not get what we wanted, right? We still get a little too much. So then let's try to find the geometric mean. So now what we have to do is remember our steps. I can zoom in too if you want. The first step is we have to add 1 to each of these values.
Just like we did right here with this equation.
So equals 1 plus A2 equals 1 plus A3. We still have our $10,000. Oh, I guess we'll do that later. Well, I guess we can do it here, you know. And in case you're curious, just so you see that we're right, if you multiply this times this times this, you know, you'll get the same result. But we want to do something more fun. We want to find the geometric mean. So we found these values. It's helpful maybe if you want to just convert this to like a number format, because we, you know, it's just a little easier to see what's going on. We don't get distracted by the percents. Now, hit the equal sign and type in geomean, just like what we saw earlier. It is now going to do that more complicated equation I put up with the n, the square root, the nth root, and the multiplication. It is now going to do that as I highlight these two things. And I close my parentheses. We good? And then we do the final step of subtracting 1. We have to subtract 1 because we threw in a 1 here at the beginning. So now it's going to do its math, and then we're going to undo what we did at the beginning. And when I do that, you're going to see that it's going to expand a lot because it's a really, you know, it's a small number, but there's a lot of places because Excel likes to put places on things. So let's just turn it into a percent and make it a little bit more manageable. The numbers are still, of course, there. We're only seeing 2 decimal places, or technically 4. That is the actual mean of this growth rate. It is not, when you have 1 and 9, it is not 5, it is 4.92%. A little bit lower, which makes sense because when we put 5 in,
We got numbers that weren't getting too high.
So this is everything we've done so far. So again, you get decimal places with these buttons way at the top. Under the percent drop down or whatever, you know, the number section, you can add decimal places or you can subtract them.
Any other questions?
So now let's check if this value is correct. Again, assuming that this is the number we care about, assuming this is going to be the interest rate on the first period and the second period, assuming the average is all of the observations. So we're going to do that. I'm just going to hit equals and have it reference this. I'm also going to lock it in place with a F4 so that I can just copy and paste it down. I'm going to put my principal up here again, so exactly the same. And now I'm going to copy and paste this value, right, this equation right here, which was doing the principal or the starting value times 1 plus this growth rate times 1 plus this growth rate. I'm just going to copy and paste it over here. Oops. I'll copy it here, paste it here. So now you see it's just multiplying these things together. It's the same. It is exactly the same. So, just to review, you guys are really quiet. Let's review what we just did. Does that make sense? Yeah, Yes. Let me show the equations really quickly. And then, but then I want to show you what we just did, but now I can't see the number. Well, let me scroll to the right so you can see. I mean, but it's basically the same thing. So I didn't want to like have to type the number or have to type in geomean this again. So I just reference this. And then I use the absolute cell references because I want to be able to copy and paste it. I didn't want to have to I mean, that was really lazy because I was only copy and pasting it once, but shut up. When you get used to Excel, you will do these things out of habit. As a side note, I really encourage you to get very comfortable with it because these little things that you do, these little hotkeys and everything, I still see people trying to copy and paste by selecting the copy drop down menu. Just for your own benefit, please just be comfortable with Control C, Control V, Control X, Control Z. Don't hit the undo button by hitting that all the way. It's just so much faster. Anyway, I encourage you to do that. So let's just review what we did step by step. We started with $10,000. I got 1% growth and then a 9% growth. And so that result, because I got the 9% growth on that 1% growth, that result is $11,009. If I assumed that the arithmetic average of 5 was the growth rate in each period, I would not get the correct result. I would get too much, which tells me the actual average growth rate is a little lower. So I followed the equation. So I added 1. To each of these growth rates. And then I used the geometric mean function. The geometric mean function multiplied these two values together and then took the square root. It took the square root because there were 2 observations. If it had multiplied 3 or 4 or 10 observations together, then it would be taking the 3rd root or the 4th root or the 10th root. Once I have this value though, with the geometric mean, I then subtracted 1 to undo this addition I did here. And then I was checking to make sure I was right, treating the averages as the period in each term, and indeed it is right. I get exactly the same result. Good? Okay, yeah?
So I understand the math behind it, but why?
So the arithmetic mean, so why do the arithmetic versus the geometric, why have 2? Because they're useful for 2 different things. Right? The arithmetic mean is going to be fine for most of the things you do. For things like I want to find the average height. I want to find the average potato crop or something like that. Because that is found just by adding things together. So you use the arithmetic mean. But for growth rates, you have to use the geometric mean. Because to figure out how much something has grown, you don't add, you multiply. If we wanted to figure out how many total potatoes we got, we just add all the anchors together. So taking an average makes sense. We want to figure out the growth rate of potatoes, we have to do some multiplication. And so we have to use the geometric. Now, the annoying thing about this process is you have to add a new column, which drives me crazy. You have to add a column where you add 1 to everything. You could try to do geomean, highlight, say +1, and parentheses close 1. You can try to do that. The problem is Excel hates that. It's like, what the hell are you doing? This is, Excel is a great program. This is an area that sort of annoys me. It's like, it's obvious what I'm doing. I want to add 1 to all the values that I've highlighted. The good news is there's a workaround. If you take this function right here and you set it into the sum product function, for some reason it now works. So if I type sum product, and you can put the -1 inside or outside the parentheses here. I'm just going to put it outside. It now works. And you can do it all in 1 step. Percent, add sum, there we go. Absolutely. It's one of my favorite equations. So what's nice is I did not have to make a whole new column to add 1 to everything. I just had to preface it with some product, geomean, highlight, add 1, end parentheses, subtract 1, done.
Replacing the Steve column.
Yep, I didn't need the seed column at all.
Right.
And to show you why this is so cool, I'm going to do the same thing in Disney sales. I just want to be able to see what I'm doing. Equals some product, geomean. I'm going to highlight all of this growth rate here for Studio. There's obviously not one for the first year because I needed a previous year to get the growth rate. So I don't know what the growth rate is for 1997. Add 1, end parentheses, subtract 1, and it's going to make it super, and it's, and then it's done. And there it is.
And now what's nice is because we can take all what we're doing into one cell,
We can then copy and paste this cell and get it for everything. We can do this. Boom. Note that 0.7 became a 0.3. That 0.7% that was right here under consumer products growth average, that was using the arithmetic mean. It had 0.7%. But when we applied the geometric mean, we got a lower value, 0.3. Because that is actually correct. Okay. Sometimes it drops a little, sometimes it drops a lot. That one only dropped a little. There we go. One last thing. This one is not nearly as complicated, and you're probably already familiar with it, so it's a good note to end on, I think. Here we have Andy's performance review. So this is a different kind of average that we're doing now. We're trying to figure out how is Andy's performance review? How good is he on average? Well, so he has, all these are out of 100. So it looks like that he got 90 out of 100 for attendance. So he usually shows up to work. Not apparently always, but usually. Maybe he's sick sometimes, that's fine. But consumers don't really like, and customer reviews don't really like him. They hate him. He's like 60. That's like almost, that's a D, essentially. But he's really great in sales, 100 out of 100. So how would we figure out how is he good on average? Like, if they're trying to like maybe do some sort of mathematical equation to figure out like his quote unquote grade or how well he does, how would we do that? Can we just do an average? Because we can add, right? There's no growth rate here. We should just be able to add all. I'm going to divide by 3. He's like an 83.33. They're different weights. What do you mean?
You have to take into account the 90 only 10% in the sales, not 60%.
Exactly. When we do a conventional average, we're assuming each input, each value is equally important. But obviously his company cares more about sales than they do about attendance. Obviously, right? In general, like some people who make tons and tons of sales probably don't have to show up that often and can get away with it. Right? And the company is happy with that. So we want to put more weight on sales, less weight on attendance, and maybe a moderate amount on customer reviews. So that's what we have this set up here. And the weights are as indicated. So then how would we actually adjust for it? How would we do this? Yep, so we can do it in 2 different ways. You are doing it the sum product way, which is you highlight one array, highlight another array, and then add each values, multiply each values together and then add them. It's the same thing as if you get a product, get a product, get a product, and then sum. This is what's called a weighted average. It is an average that you have individual values to. You apply a weight, which is always expressed in terms of a decimal. Usually it's expressed in terms of a decimal, some percent value. And then once you have all these individual products, you then add everything up. You do not then divide by like how many you see. Here's the equation for weighted average. The W's are the weights. Note we take the weight and we multiply it by some corresponding value. This goes the mathematics way of telling you to match the individual values. So the first weight goes with the first observation. The second weight goes to the second observation, and so on and so forth. You will note, however, that there is this denominator. What does the denominator represent? Does anyone know? Yeah.
All the weights added together in case it's not up to 100%.
Exactly. All the weights added together in case it is not exactly 100%. Why do we do that, Michael? Yeah. And let's see what happens when we do that with poor Andy. Let's imagine we don't have information on his customer reviews. Like those haven't come in yet, they're still being processed. So we just don't have that information. Take a look at what we have. We have two scores from him. One is 90 and one is 100. Those are both really great scores. Yet the weighted average is 69. That's a pretty low score. What happened? Like, well, what's going on? We assume that there's 100% built in, right? The reason why we don't divide the first time is because, as Michael noted, all the weights added up to 1. Divide by 1, you get the same result. In order to normalize this, in order to correct for the fact that we don't have all the data, we have to also divide this 69 by the sum of the weights. What is the sum of the weights? 70? So do we divide by 70? Close. We divide 0.7, right? Because these are percents. If you divide by 70, note you will get a lower number. That does not make sense. What makes sense is a higher number, and indeed that's what we get, 98. 98.7. Appreciate the logic of this result. What does the company care more about, sales or attendance? Sales. Is this closer, is this 98.57 closer to the sales value or the attendance value? It's close to the sales value, right? So there's a symmetry here, right? This is not 95. If it was 95, then this would have equal weights, right? And we can see that. Or more accurately, if this was 35% and this was 35%, we would get 95. If there were equal weights between these two. And that's really all an arithmetic mean is. It is a weighted average with equal weights. It is a weighted average with equal weights. Because if all of those W's are the same, you can factor it out. And since the W's are less than 1, you can then bring them into the denominator, and if this equals 1, then it goes away, and now you have the same thing. Does everyone follow that? Let WI just be W. So this is all the same, this is all the same. Let's also let the sum of all of them equal 1, which means this goes away. Because it equals 1, so we can cancel it out. If, and W is less than 1, of course. The sum is equal 1. So, we can factor out the W. Now, if all of them have the equal weights, what must the value be? In fact, actually, I can keep this here and I can show you more accurately. Pi equals 1, and it's been a while since I've done this. If there are 8 observations, and all observations have equal weights. What must be the weight of each observation? 12.5 or 1/8, right? I was going to do 1/8. It's easier to see the fraction. Right? So if all observations have equal weights, the weight is 1/n, right? By definition. It has to be the same. If you want to vary it between n's, then it's not equal anymore. So we can do this. Sum all the way out to n, 1/n. Well, if you add 1/n together n times, it's just going to be equal to 1, right? Do we see that? And we can put that n then in the denominator, and we have the same thing. We have an arithmetic average. So everyone see how we got from there to here? Right? The weights were the same. If the weights are the same, they have to be, we can factor it out, and they have to be 1/n. If these weights are all 1/n, then 1/n added together n times is just 1. And so then we just put that in the denominator, and we have the sum of everything divided by n.